Good afternoon, everybody, and welcome to the BDTI Skills Studio. Today we have our final workshop of the year. We'll be discussing natural language processing and data visualization to enhance citizen participation. We'll be discussing a really interesting use case from Vanta in Finland, I believe it is. And yes, we'll go to the next slide, please. Here's the running order for the day. So we'll have a quick introduction to BDTI. We'll then kick into the workshop content. There'll be time at the end for a Q&A and a short wrap-up. Please do share your thoughts during the session. It's always great to hear how it's being received, and if you've got any questions during, please do either pop them into the chat, or there's a dedicated Q&A widget which you can activate by clicking on the three dots beside the chat bubble. Do share learnings with your network and register for more. We've got one more event this year and one in January, which we'll discuss at the end of the session. So the next slide, please. I'll pass you on now to Maria Claudia, who will give a quick introduction to BDTI. Thank you and enjoy the session.
Thanks a lot, Kim. Hi, everybody. Welcome back to our webinar. We just want to spend some words about the BDTI program that you already know very well. So it's already from 2019 that this program has been started, founded by the Digital Euro program, a huge initiative from the European Commission to help member states, specifically in this case, to help public administration in improving in their data literacy journey, I would say. And what it was offered was this big data test infrastructure that was a kind of, let's say, playground for public administration, even small public administration, to play around with their data, open data, and try to define and a meaningful use case to support a data-driven public sector. The big data test infrastructure is something that is deployed in the cloud. So one of the big advantage was and is the fact that you don't need to waste your time setting the system and also all the different tools. And this was covering a 6-month period. It is something very, I would say, very similar to when you are also trying to propose proof of concept and prototypes in general in the research and innovation field. If we move to the next slide, you can see some interesting numbers about what have been doing in the last years. So we execute together with public administration different pilots, and if you are curious, you can find a nice summary of these pilots in our website. But they were mainly focused about issues and challenges in the field of mobility, sustainability, smart cities, urban planning, but also focus on climate change and climate resilience. It was a very nice journey because we had the opportunity together with the team, with Kim, Aurora, Alex, and all the others, to exchange with many public administration. The nice part is that we interact with public administration, not just at national level, but also at local level. And this is where you can really see impact of public policies that are defined at the highest level, Commission, on the real needs of citizens. And finally, this webinar is part of this. We try to disseminate and also to foster exchange of knowledge and good practices in the field of public sector data skills. That's where we are organizing these webinars. Tomorrow we are going to have another very interesting event. Feel free to subscribe, where we are presenting use cases from cities around Europe. Then, if we move to the next one, just a quick recap about what we are offering and what is going to be also available in the open source code of BDTI under GitLab. Is this set of tools that could be also inspirational for your work. So as you can see, we are trying to cover all the important data journey steps, from data collection to data visualization. And all of these tools are completely, I would say, open source. Open source is an important keyword in general in software development, even more if you are working in the public sector. because we really need to focus about sustainability and reusing knowledge and the money, public money that have been already spent to develop something meaningful. So I would suggest that maybe if you're working in this field, these are good tools that you can try also to adopt in your public department or in your agency to start playing a bit around data. Then if we move to the next slide, we can see a nice summary of a real world, as the title mentioned, data-driven solution across Europe that have been developed with BDTI, with our platform. So there is an amazing example from Turku, where they are creating urban mobility solution to improve public transportation, basically analyzing just spatial data, but also analyzing mobility data. So how people are moving in the city and how government, in this case, this municipality, can create services that are more, useful for citizens. Then we had another very inspiring example at national level, in this case from Greece, where they were trying to collect all the public services and try to expose them in let's say in a format that is called linked data, in a semantic web technology, in order to make these services interoperable and also centralized. And this pilot also was recognized as one of the best pilots in the last e-governance conference. And they also published an interesting paper on that. Then finally, we have other two interesting examples. Again, one is at municipality level, so at the lowest level, from Bochum, from Germany. This team was really, they are still implementing this pilot, and they were trying to collect data from the trees around the city, and also they implement a machine learning model to predict important parameters, for example, about the resilience, humidity of the trees around the city, and also to try to find correlation, between pollution and other important variables that usually you need to monitor if you're working in the environmental department. Then the BDTI was also used during COVID to quickly implement data-driven solution to support, let's say, policymakers. They're deciding about COVID lockdowns, and also about big and important decision in their country. You can find all this information in our website, and here you have also the QR code to directly go to our pilot stories. Thanks a lot. I think we can move to the next slide, and we can, what we want to do with this slide is really to summarize how this journey has been made, and also all the materials that we really want to share with you, and we ask you to share with your colleagues and with your network. So in our website, you can find tons of materials about defining your use case. We are going to publish very, very soon a list of more than 40 use cases from different cities. You can try to discover also the tools that we are pushing for having a data-driven journey. And you can also try to have these tools installed in your own environment. Then we highly recommend you to check again all these webinars that are public available. We have a YouTube playlist, and at the same time, we publish all the code behind these webinars in open source. So you can easily fork the repository. You can really reproduce step by step what we have done in the last month together. Finally, the main goal is to share all this knowledge together with maybe other municipalities, other colleagues that are also interested in these learning opportunities, and try really to move forward with this data-driven public sector. Even more nowadays that there is a lot of enthusiasm around AI, it's really mandatory to build solid foundation around topics like data interoperability, data quality, and data accessibility. Let's move now to the main content of this workshop. As Kim was just mentioning, it's going to be very, very interesting because we are going to analyze data, text data in this case, And we are going to discover something about NLP, natural language processing, that it's a branch, let's call it, of data science, and even more nowadays about machine learning, that is focused on text. So how we can extract information from text, and how we can also try to understand a little bit better citizens' opinions, and also how we can improve services from the government side, listening to citizens and also to collect information like this service. So thanks again for your attention. Now I give the floor to Jordi and enjoy the webinar.
Thank you, Maria Claudia. Welcome everyone. So as Maria Claudia introduced, so that's the use case we've chosen today, which is working with surveys from citizens in Vantaa in Finland, and use that as example for doing some introductory work to natural language processing, to use LLMs and to the AI trend that is happening right now. So as a brief introduction, let me just, I don't pretend to be to write the master thesis here on what is NLP and LLMs, but just to put the basis on what is natural language processing. This is a branch of the artificial intelligence trying to make computers and humans interact with natural language. So pretending that we speak to a machine and they understand and replies us back. That's the dream, right? So why or when are we using NLP? Any chat or virtual assistants that we are very used to have in all the websites and applications right now. We will see the example today to use it for language translation. This second point, we will do it implemented today, language translation from Finnish. I don't speak Finnish, so how can we work with data that is in several languages? We will also do today some sentiment analysis, an initial step on how can we analyze quickly massive quantity of texts, but it can also help in the text summarization, give me a summary of a text. That's the kind of the typical use case that we are very used today to the commercial tools available in the marketing. But it has but all that technology improvement have a drawback, right? And I wanted to illustrate that with this image here. So what I did is I took one of these commercial AI chats and I asked, can you create me an image to introduce NLP? So I asked, can you generate an image to put in this webinar, right? Then I didn't completely like it because it was not explaining the steps of natural language processing. And I added the second sentence, which please add the key applications and a diagram of the NLP process. I did that with my very limited knowledge of the topic, right? And the system generated that image that if you don't look it carefully, it even looks nice, right? Then if you check carefully, there are a lot of wrong text. There are even some typos, mistakes. And I don't know if it's even correct. I'm not the expert to say if all the steps, there are some arrows that look like arrows. There are some others that are not arrows. So, looks like real, but you need to question if that's really real or not. Accelerated my time to create the PowerPoint, but it's my responsibility to make sure this is correct. So please don't take that as a correct image, please. So let me introduce another buzzword that we'll be using today, which is LLMs, large language models, right? And what are they? So LLMs are trained AI models designed to understand human language, so understand when we speak, and generate human language, so things that we can understand, right? They've been trained with all the encyclopedias and all the text that they can find in the internet, right? They trained it, and as I said in the points here, when you give a piece of text to that LLM, to that model, he tries to generate, basically predict, is a predictive modeling, to predict the next word. So you give 3 words, he predicts the 4th. You give the 4th, he predicts the 5th. If you do that recursively, it looks like it generates paragraphs of text, right? But that's the concept of the chat. But it's kind of generating word after word, which it means is the chatbot does not understand your question. It just finds the right answer to match the next word attached to the previous word. And that's why it's convincing, because it really do a good prediction of normally when humans speak after this word, they normally put that other one in that context that we are talking about, right? So it's a good quantity of text and words all together, but the answer might or might not be correct. So first, it's your responsibility to check the answer. And also, as we will see today, it's your responsibility to do the right question, right? And give enough context to the question to have a right answer. There are many open source LLMs, right? As well as there are many commercial LLMs. What's the difference and when to use ones or the others? The open source sometimes might be limited for very complex tasks, not because of the model itself, but normally for the level of resources or the infrastructure that they might need to run. This is really large processing and very resource intensive, right? So what will happen, and we will also see today, the example is there are the large models, and then there are reduced models that can be suitable for our initial steps, right? Or for the prototype. So that's what we will do today. We will use a limited large language model, and we will see that it works pretty well for the pilot that we are doing today, right? So it's a good step to start working. I introduced the concept of cost, right? So how are these things priced? And again, there's plenty of information in the internet about NLPs, LLMs, and chatbots and how they are priced. But again, to put a bit of a context and to introduce an important topic today is the tokens. So the models, they don't speak, they don't understand, they don't process words, right? So the only thing they do is coding words, and that, as you see here, there is a text here, once upon a time in a magical forest, right? The Cornelius bunny whiskers. It's a set of words that they are coded into numbers, as you can see below, right? And those numbers is what the algorithm is using to find that normally after an 11, they put a 1254, right? And after that, they normally put a 3264, and that put words together. So this concept of breaking words into pieces, these pieces are tokens. And as you see above, there is not always a word a token. Sometimes a word is split into three, like whiskers, right? Or some others are kind of just the H being a token on itself. This is just important, this concept of token, because this is what these models are priced about, right? So it's X amount of euros per million tokens in or out. So that's how you size the use of the model that you're doing. With that, right? And now I'm going to be moving to the use case, and I will introduce what we will do today. So as I go through that, check on your experience, check the things that you are doing, identify, where you have similar opportunities to do the same. Think beyond the workshop, right? So try to apply that to your own environments. And again, as Kim said at the beginning, please feel free to put in the chat or in the Q&A your questions, and we'll try to solve them all after the session. Let me introduce you the use case today, the example we've chosen. So how can the city of Vantaa, so this is in Finland, they've launched surveys, right, to their citizens. And how can we improve the participation to these surveys based on the insights that we can get from the 2020, 21, and 22 data available, right? So that's what we are going to try to do today. How can the city improve that survey participation? How do we do that? So, and also taking point here from Maria Claudia about the open data, right? So what is important is, we will be using the open data service from Helsinki region, where all this data is shared, made available, so you can reuse it and share with the rest of organizations and public sector, or even private sector. So having the data open and sharing it with the community helps developing and reusable solutions. So again, This is the example we use from Finland. We also recommend to check the data.europa.eu, where there are millions of open data sets, very relevant for the different topics that you might be interested on. So let me introduce you to the data sets we'll use today. The first one is this surveys itself, right? So the data sets are all the responses from the city on this kind of annual survey they do, right? So there is a little set of questions that they do. You will see that in a second. And this is the kind of the results we get, the ID of the survey, the different answer to the numeric questions that they were asked about, and a free text about their comments about the survey or about the city. This is where we will try to find insights today on those texts here written in Finnish. So we have that as an intro data set. We also have the question itself, right? So this is what were the questions that they were asked in each year for each topic, and they had to kind of choose, vote, with the answer 1, 2, 3, 4, 5, or 6, right? I'm not even understanding what the answer is, right? So that would be part of the initial step. What else we'll be using today? And as I mentioned, we will be using the Llama LLM, right? Reduced model from it, right? So again, you will see in the demo, we're using a couple of libraries, right? From Hugging Face, also open source, and the reduced model we are using today is the Meta AIs. What happens in this reduced is lower performance, so it takes longer to do some of the questions. So that's why we will see a recorded demo, because some of the processing takes really long time to happen. The small size, it also brings to less accuracy on the language understanding and generating. So you will see how Leo then solve that accuracy topic. It might struggle to get the context. So a very large model, you put the first question, like my example on generating an image. Can you put me an image on an NLP? And then I put the second question, can you fine tune on something and understand the context I'm on talking? While here we will have to set up the context, right? And have some less features. But it allows us to do the demo and the prototyping, as we will see today. These data sets, we will use it with Jupyter Notebooks today. We'll be storing the data in MongoDB, and we will visualize it with Metabase as a visualization tool. Moving forward, this is the high level of the steps we will see today, and then I will recap it after the demo. We will set up the BDTI environment. The idea, as Maria Claudia said, is that you can repeat that at home, right? So you can repeat that in the BDTI environment by your own with the code we will share. So we'll set up the environment, we will understand, and we will fetch the data from the data source. We will translate Finnish into English, and we will prepare the data, and we will get some visual, some understanding already from the data. And then we will do some sentiment analysis to see if the feedback that we are getting is good or bad about the city and about the survey. Right? Let me go and play the demo right now. Please feel free to send the questions, and we will catch them up all at the end of the session.
So let's get started by creating the services that we'll use for this project. If you go to the landing page for BDTI, you can click here to access the service itself. You'll be asked to use your EU credentials, but after that, you'll be welcomed with this dashboard. And if you click here, you can see the list of available services for BDTI. In this case, we will need a Jupyter Data Science notebook, a MongoDB to store the dataset, and then Metabase to visualize the results. You can create them one by one. So when naming services, it's recommended to use names that are descriptive of who created them and for what they're useful. So in this case, let's say something like Jupyter Notebook for the webinar by me. So initials in the end. Training status put in shared so other people in the team can access it. Group is just select your group. Then for the configuration, these are presets that determine how much memory and CPU usage you have. In this case, we will be using some two large language models that are relatively large in terms of memory. So we will use a medium configuration. select default values for everything else, and then copy this password and paste it somewhere. Just click launch. These take a bit to load, so in the meantime, let's create the other ones. For the MongoDB, we will, well, that's the same. MongoDB, the webinar, initials. The dataset that we'll use is relatively small, so let's choose a micro configuration this time. And same as before, copy your password somewhere. It does require a username, so let's do that. I hit launch. And finally, let's create the metabase service, same as before. Base, initials, and group. And let's do a small preset this time. Hit launch. And all of the passwords that you selected earlier, you can, if you lost them, you can go to my data here, and there's a list of all of the passwords and usernames that you created. So it's okay if you forgot them. And all of the services that you created will be deployed. And if you go to my services, it will list all of the services that you have in the BDTI platform. So we will open the Jupyter notebook that we created. And it should prompt you to enter the password. So you paste it in and put load. And after that, you will be presented with the notebook right here. Okay, so we will create a project folder first. Let's write a new folder. Let's name it Finland. Inside, we create a file named requirements.txt. These are all of the required libraries that we'll need to have installed. So let's do that. Okay, so these are the libraries that we'll use for this project. The first one is GPT4All, which is a library that handles open source large language models and lets you use them very easily. Then we will use for translation, a Hugging Face model. So we need all of the Torch and Hugging Face transformer libraries. And then finally, for the MongoDB, we'll use PyMongo. So we write all of this in the TXT, and then open a terminal and write pip install -r requirements.txt. I'll be right back. And it's done. Okay. It took a few minutes, but we're back. Now we can actually start to prepare the data. We can go here and right-click New Notebook. It will prompt you to select the kernel, just leave the default value. And we'll name it something like prepare data. Say, but before we get started, I want to actually show what the data looks like. So I downloaded one of the Excel files that we were using. It's a survey in Finnish. So each question has a code. As you can see, the columns are named after the questions, the question codes, sorry. And then there's a column named ID, which identifies each user. And the row represents the values that he picked. And some are multiple choice questions, some are checkboxes. So in this case, when one is selected, it's because the checkbox is checked. And when it's null, it's not checked. And then finally, there's usually a open-ended feedback question where you can write anything you want. Then on the other page, we have the actual questions. Again, with the code in this column here. Then this is the question itself, and these are the choices that the user can pick. So 1 equals this first question option, then 2 is the second option, and so on. And we'll need to translate all of this, first of all. And then also in this table, we want to replace the alphabetic and numerical values with the actual choices that the user picked. So we can then visualize it later better. So let's start. So obviously the first thing we'll do is download the data. Start off by importing the libraries that we'll use, and then immediately we just download the Excel files straight into a Bytes object. After that, we loaded into a pandas data frame using this read Excel function, and it's ready to be used. As a matter of fact, if I print the data frame, it's the same thing I showed you earlier. So yeah, we will start off with translation. Since we want to use everything open source, we will use publicly available machine translation models. In this case, we will use one published by Opus Machine Translation, which is a project done by a research group in the University of Helsinki. And the idea was to put as many open source machine translation models into one resource as possible. In our case, we only want Finnish to English, but as you can see, there's almost any combination you can think of. So we import this one, so Finnish to English, and we load it into a usable model. This takes us a second to load, so I already did that, but we put this test string here to translate it. And if you run it, you can see it says this is a test for the translator. So the next thing I did is define this function. The idea behind it is it takes a value, and if it's a null, it returns a null as well. But if it's a string, it translates it from Finnish to English, and then returns it on translation. And this function is then applied to every single cell that has Finnish in it. One thing to note is that we have 3 years worth of surveys, so every step I take has to repeat it 3 times. So this might look like a lot of code, but it's the same step applied over and over. So as you can see, it takes a cell, applies this lambda function, which is the translation function, and returns the value to the same cell. It does this for all of these cells, and then renames in columns. And then for the second page, which contains the answer options and the questions, we do the same thing. So we load it, we rename some of the columns, and then apply the translation functions through all of the cells that have Finnish text. This will take a bit, since it's all running locally, and it's a lot of text. Last time I did this, it took like 20 minutes. So I will cut the video and I'll be right back. Okay, so everything is translated now. If I show you the data frame, you can see that for the questions and answer options, everything is translated, and the same with the answer data frame. Now we will move on to data cleaning and making everything presentable. First of all, we want to swap out these numbers with the actual options that the user has picked. In this case, for example, this user picked option 3 in this question, option 4 in this question, but we want the actual option to be written in the cell. There's also some other data cleaning that needs to be done, and so we'll get onto it. First of all, we'll make a copy for safekeeping, of course. So let's do that. And then we'll get a list of all question codes that are either a categorical, so multiple choice question, or a checkbox question. This snippet of code does that. So if I do this and then print out the list of codes for 2020, you'll see that it prints out a list of codes. And then using this list, we will replace all of the checkbox values from nulls to zeros. Just as a reminder, this is what the checkboxes look like. When the box is checked, it's a 1, but when it's not checked, it's a null, and we want it to be a 0. So this is what this part of the code does. So this lambda function here does if null, then it's a 0, else a 1, and we run it for the 3 years. Okay. So now that this is done, if we want to check the contents of a checkbox question, we'll see that it's either a 1 or a 0, and there's no nulls, so it worked. So next up, we have to replace the values of the categorical options with the actual options they picked. So if we look at the Excel file, the questions are in this format. So there's either a numerical option or a alphabetical option, and they are separated by semicolons or commas. And the format in this dataset is very consistent. So in order to parse out the options correctly, I use a regular expression, which separates these strings into numbers and then the values. So if I run this, you can see that each expression gets separated into a key and value pairs, where each key is the number of the option and the value is the actual option itself. So option 1 is living alone, so 1 is the key and living alone is the value. So with this function, we can now create another function that is designed to replace the cell values of the categorical question. So if a cell has a value of B, and then you pass the dictionary with the options A, B, and C, it just replaces the letter with the actual option. Another thing is that sometimes this EOS term comes up, and it basically means that the user doesn't want to answer the question. And so this is put in place instead. And so now for each year, we run these loops, which run through all of the questions and then replace these cells with the actual options that the user picked. So if we run this, let's run this too. We see that the result is now, instead of A, B, and C, it has every single option put in place in the entire questionnaire, which is what we wanted. So now this is done, I'm going to do one more transformation with the questions table. I'm going to transpose it. 1 second. Just as a reminder, this is what the original table looks like. And so we have one column for the codes, one for the questions, and one for the answer options. The answer options one is going to be completely ditched because we already used it. And then we're going to transpose, which means to tilt the table. So the column names will become the question codes, and the first row will all be questions. So this is what this piece of code does, and it's very long. So I'm going to skim over it. If you want to read in detail, it's available in the GitLab repo. But this is the end result. Basically, the codes are the column names, and then the first row is just a list of questions. This is useful for us later if you want to do joint statements with the other table that has, if we look up, the codes as a column names as well. So now it's ready to be uploaded to the database. We're going to create a connection first to the MongoDB client by importing PyMongo. We use the username and the password we created earlier, and then the IP address. You can obtain it by going to the My Services section, and then finding your service, and clicking copy. It will copy the IP address to your clipboard, and you can paste it here. After this, we establish a connection and create a database called Finished Surveys that will contain a bunch of collections. In MongoDB, collections are the equivalent to a table, more or less. So we create one for the questions for each year and one for the answers of each year. Then we go one by one for each data frame, and we upload the content to its corresponding collection. So now that this is done, if we go and try to read a collection, we will see that it has a bunch of content, so we know that it was uploaded correctly. And now we'll move to Metabase. Going back to the deployments list, we will open Metabase now, the one we created earlier. And it will prompt us to create an account. So I'll do that real quick. And we set to English, and we fill out this. 1 second. Okay, so that is done. And click Next. And here's where you add your Mongo database. It's not in the main options here. Let's click on MongoDB. And here you fill out, well, let's do that really quick. Finish surveys. The host is the IP address. The database is finish surveys, as we set it earlier. The port is 27107. Actually, let's remove it from here. The username is this. And the password, I'll copy and paste it. 1 second. Everything is then defaulted, and then we click connect. We finished building now. It took a few minutes. And finally, just disable this and click finish. It will bring you to your dashboard. if you go to browse data here, it will list the finished service database that you had. And here you can explore the 6 tables that we created. And for example, let's go to the answers one from 2020. And you can explore a lot of the fields and like ask for summaries and such. We'll do it in a second. As you can see, everything here. So let's try to get some preliminary insights into this data. Let's go back for a second and open the questions table in a new tab. And we're going to try to look for something interesting to look at. If you click on any of the fields and select View Details, you'll get a full list of all of the questions. Obviously, if you design the questionnaire, you're going to know what the questions are, but in our case, we don't. So I think 202 was interesting. Basically asks if the user knows how he can contribute to the development of the city. And then another interesting one is the final one. So age, gender, family form, mother tongue, so on. We get them filtered by these results to see how different populations answer the questions. So we go back to the answers again. Load it. So it allows us to create quick diagrams to show how different people answer questions. So we click on summarize, and let's summarize by code 202, which was that question. Click done. And it shows a bar chart of what we asked for. Let's change this to a pie chart. That's more useful. Yeah. So now we see that there are more people who disagree about knowing how to influence their local neighborhood than people who agree. If we can then apply some filters, if we go here, we have the same questions as before. Let's go down and let's see how gender affects this answer. Okay, so in this case, 40% of women somewhat disagree and strongly disagree, and then 20% agree. If we change this to men, let's see how this changes. So clearly there's a discrepancy here, and of course, people who do these surveys use this as a starting point to investigate other things further. This could be one of them. Let's see other filters. Something more innocuous. Let's see how the response type affects the answer. So if it was sent through internet or through mail. So the internet is roughly almost 40% somewhat disagree, and if it by mail. In this case, it doesn't matter that much. But as you can see, you can basically apply as many filters as you want and get insights about the responses you got. Once you have your diagram designed, you can then save it. You click in the top right here, and let's give it a name, influence and development by gender. In this case, I have the filter on that is by gender for women. You can then add it to dashboards later, but let's not do that now. So now if you go to the sidebar here, you can go to our analytics, and then you have your chart here, where you can consult it at any time. This chart also gets updated, so in the future, if you add more data onto your data sets, this will get updated on real time. We're going to see more about this in a second, but first let's go back to the Jupyter Notebook to do some sentimental analysis with LLMs. As I showed earlier, in these surveys, this is one final question, which is basically an open-ended general feedback question where the respondent can type in anything he wants. And this is used both as feedback for the people doing the survey, but also for the local government in general. So we're going to do sentimental analysis on it, which is basically analyze what the comment is talking about, and then aggregate this data along the entire survey. And for this, we're going to use large language models, which is, to get an idea, basically what powers chatbots like ChatGPT or maybe Google Gemini. And we're going to try to extract insights from the comments. For example, the first one, I'll show in a second, is basically a simple, is this a positive comment or a negative comment? We're going to use open source language models. In this case, we're going to use Llama 3.2, which is Meta's or Facebook's large language model, which was released like a few months ago, I think. And we will use a reduced version of the model because usually LLMs are extremely large. They can weigh up to hundreds of gigabytes, and running something like this in a Jupyter notebook is not reasonable. Aside from the fact that would take ages to generate responses. So we use a 1 billion parameter one, which is relatively small. But in exchange, it loses intelligence, you could say. So you will see that you basically have to hold their hand as you instruct them what to do, so it doesn't stray away and start talking about nonsense. But it's still useful, and you'll see the results in a second. I created this Jupyter notebook in advance because since it will take a long time to generate responses to all of the questions, which is around 200, I think, and we will ask several questions to each response, so that in total it took over an hour. So I created in advance, and I will show you the results here. At the start, it's the same as before. We load the MongoDB database, and we take the contents of it into a data frame of the answers. And note that we imported GPT4All, which is a library that we use for the LLM. And we also, while we're at it, we renamed some of the columns. So the feedback column will be named feedback, and the K0 question, which is the age, and the K10 question, that is the gender, will be renamed as age and gender. So it's clear what we're talking about. You can see the data frame again, it's the same as before. And here we start loading the model. So as you can see, Llama 3.2, as we said, 1 billion parameter version, quantized. Quantization is a technique used to reduce the size of the model. You don't have to know about this, just ignore it. These warnings are not really relevant. And here we define the function to generate a response. Basically, it takes the string, passes it to the chat session, and generates a response, and returns it, nothing else. It limits it to 300 tokens, which is roughly 200 words, because sometimes this LLMs start talking and generate entire paragraphs that are not really relevant, and we don't want that. So if it hits the 300 token limit, it cuts it off. The first thing we're going to analyze is the sentiment of the messages. So this function here, this is what it does basically. If it's a null value, it doesn't say null. And if it's a string, it then passes it through the LLM using this prompt. And I'll read it out. The following message was sent as feedback for the survey. Tell me if the general sentiment is positive, negative, or neutral. The response should be given by either writing positive, negative, or neutral. Nothing else should be written. Here's the message. And then the message is appended. And the idea is that you send this to the LLM, and it generates what in its own opinion is the sentiment of the message. In case it either hallucinates or it doesn't respond in the correct format, it will retry 5 times, and if it fails 5 times, it will say that it's neutral. And then this is applied to all 3 years of the survey, and as you can see, for each feedback that was sent, it's either positive or negative. So this one talks about how nice it was to get a survey, so the sentiment is positive, and this one says yeah, sarcastically, so it says it's negative, and so on with all of the questions. The next question that we asked is whether or not the messages sent in the survey contained any suggestions of what to do, or something to change, or whatever the user wants. And so in this case, the prompt is the following message was sent as feedback for a survey. Tell me if the comment is requesting or suggesting changes to anything, answer with yes if it demands specific changes to anything, or no if it doesn't. And as I said, this is a large language model that is not very intelligent because it's very small. So we have to specify even more. So a generally negative message doesn't count as a suggestion for change, but it has to name a specific thing to be changed. Here's the message. And on top of that, I write out your reasoning first step by step, then put the answer in the end saying either yes or no. The reason we sometimes ask large language models to reason out the responses before answering is because it is shown to greatly improve the accuracy of questions. So if you have a open source language model that is very small and you have trouble getting accurate answers to your questions, ask it to first reason out the steps it takes, and then in the end give the answer, and it will most likely improve. Then we provide some examples of correct questions. This might sound superfluous, but it helps a lot. And then, same as before, we retry the question if it fails, and then after 5 times, it just says no. This is applied to all of the questions. As you can see, for each question, it is either yes or no. For example, in this case, it would be nice to have the magazine, this request changes, yes. The idea behind this is that if you're tasked with getting general feedback back to the government about this survey and maybe list out specific changes that people are asking for, this might help you to filter out responses, and it will take you less time to sift through the suggestions. In this case, it's a rather small survey. It's like 500 responses per year. But imagine you have maybe an online survey that has tens of thousands of responses. This might be a great improvement in your speed of working. It has to be noted that these responses are not always accurate. For example, in this question here, why such a question? That's not a suggestion of anything, but it says yes. And the reason it probably says yes is because asking why this final question exists might be a suggestion that the question could be removed. But obviously, this is kind of a subjective opinion. And the point I'm trying to make is that this is not an exact science. And there is some wiggle room on how these responses come out. So, yeah, just have it in mind. The final question we'll ask the LLM is asking if the negative feedback specifically, if it's constructive criticism or if it's just complaining without mentioning any change or anything. And the idea was to have a bit of a analysis of toxicity maybe, and we thought it could be interesting. This one is still processing, so I'll cut to when it's done and I'll show the results. Okay, so now it has completed the processing, and as you can see, there's a new table that says constructive criticism, yes or no. And for the positive messages, it doesn't even check, so there's a null value for them. We upload all of this new data into the old tables with an observed action. And that way we don't stack new rows in the database, instead we replace the old ones. On top of that, we created a new table that is called feedback. And it only contains the feedback messages, the new data we generated, and age, gender, and year of the respondents. This is so we don't have to aggregate the tables later down, and we have them all in one table for analysis. And then finally, we upload this to the database, and we can finish with the Jupyter Notebook. So now that the data is uploaded to Metabase again, not to MongoDB, we have to synchronize it with Metabase again, since we changed the schema and then added another table on top. So if we go to the main dashboard and click here in Settings on the top right, we can admin settings. We can then go to Databases, click Finish Surveys, and then resynchronize and rescan the schema of the new tables and the modified tables from before. So now we go back and go to Browse Data. We'll see that we have the new feedback table, but also in the previous tables that we already had, we have the new columns added. So now that the table is loaded, we can go to the end, and you'll see that the new columns have been added. So the gender columns have been renamed, and the age as well. we have the feedback column, and the sentiment, requested changes, etc. So everything that we asked for is here now. Okay, then let's try to get some new visuals on the new data. We open the new table of feedback, and we will try to summarize by, first of all, sentiment, but then also, let's do sentiment first. As you can see, the negative ones surpass the positive ones by almost double. It makes sense if you think about it. At the end, you're more likely to respond in a feedback question if you had a bad experience than if you had a positive one. And if we split by age, because you can stack different groupings, we will see that this doesn't vary across ages. In fact, it's consistent across all age groups, except the young ones, although there's only 4 responses, so this isn't really representative. Now I want to show how you have to be careful with some of these analytics. For example, I could create a filter for negative sentiment, and then summarize by, let's say, gender. Yep. It might give you the illusion that for some reason women are a lot more negative when responding than men. However, this doesn't take into account that the proportion of women and men responding to the survey in general is not equal. So instead of this, you have to do it via percentages. Second, if instead of doing what we did earlier, we filter by gender and then group by sentiment, we'll get a completely different result. Once again, I put a filter, and I filter by man and woman. If you would then switch to a pie chart, here, the percentages is roughly 70% and 30%, and then if I switch to a male, it will also roughly 70% and 30%. So yeah, just be careful with this kind of thing. Let's look at some of the other data points that we created earlier. So for example, the constructive criticism one, let's select it. And we can see clearly that the non-constructive criticism far outweighs the constructive ones, which is what we would expect, honestly. However, we also see that the null values are also present in the bar chart. And that's because, as a reminder, the positive comments didn't get checked for constructive criticism because they're positive. So we can filter this out. If we go here to constructive criticism, and we can select that it has to be either yes or no. And we apply the filter. And so all of this is cleaned up. And we can do more stuff. So for example, let's break this down by age. We group it together. Now you might think that for some reason, magically at age 60, people stop being mean. But the thing is that at that age, the response rate is a lot lower. So the amount of data that we have available stops being significant, and I don't think it can be relied upon to make assessments. If we break down by year, for example, let's see what we get. Okay, that's pretty decent. We can see that in 2020 and 2021, people were a lot meaner in the responses, and for some reason in 2022, a lot more constructive criticism was given. Maybe it's because of the pandemic, people were tired, or maybe, I don't know, who knows? I'm sure the people who made the surveys know better about this. What else? Let's check the last variable missing, which is the request for changes. And this time we'll filter by gender. Let's see. Set it to woman here. And let's make it a pie chart as well. So we get percentages. So at a first glance, women make around 60%, around 60% of comments don't make suggestions, and around 40% do make suggestions. If we then switch this to men, we see then clearly there's a difference now, roughly 75% and 25%. Now, we could go on with this, trying to find different trends in the data, but in the end, it's just meant to be as an example, the exact conclusion we take from this data from years ago is not really relevant. We just hope that we showed how you can use large language models as a tool to extract information from text that's written by humans, and then scale it in mass to extract insights from surveys and maybe comment sections or reviews or whatever you want. Then hopefully you saw how you can use Metabase to visualize this data, applying different filters and different plots to show trends and compare different populations against each other. And yeah, that's it. Now we're going to end the pre-recorded part of this demo and then hand it back to Jordi. Thank you.
Good. Thank you, Leo. I think it was a good demo. So conscious of time, let me quickly recap on what we've done, what we've seen by Leo, and then move on to the questions. So again, we saw how we set up, how we got the data from the Excels, all the translating piece on the text. I think that this is kind of something that are very reusable for any other all your use cases of playing with text, and that finally creating those features, those variables about the sentiment and the kind of the feedback about the free text. This is what we wanted to show you today, and then how to visualize and analyze the results on top of that data. Why all that, right? So the whole point, let's try to go back to the initial use case. So how can the city of Vanta improve the participation and trust in the local governance based on the insight from surveys? So what we were trying to do here is get the tools to identify the factors, what influences on the number of replies, on the kind of replies we get, seeing how people interact to 1 year, then can help us improving the questions for the following year, or getting to more people or to different kind of ages, so that can help improving how do we use the surveys, as well as getting the feedback of the information that they tell us and have an impact on the governmental actions, right? So what could we do out of this analysis, right? So enhance the communication channels, other than email and by internet. Maybe we can have other ways of replying, keep the people informed of the participations, and also see the trending over time if people is getting used to get the survey, so they can reply more, right? Another option would be to recognize the active participants, so people which is actively replying, create any kind of reward or recognition or something to motivate other people to engage on that and get, create the culture of participating into the public life. And finally, kind of by showing and sharing those analyses, this data transparency and data literacy that we were explaining at the beginning with Maria Claudia also, right? So increase the transparency of public administrations, creates trust, and gets engagement of people over the government actions. Getting to the end. So what we try to show today is how to use the available tools on NLP, on large language models, how to can apply to process text processing, find the feedbacks on a text. Here we use the example of the surveys, but that can be applied to any of your examples or use cases you have in your different domains. So get yourself familiar with it. You can use the BDTI platform to create some of these use cases and help your community. We'll be sharing all the code that you've seen today in the BDTI repository, and so you can try to reproduce some of the snippets and apply to your specific use cases. And with that, Kim, I'm handing over back to you for getting into the questions.
Yes, thank you so much, Jordi. And thanks again to the team for that really interesting presentation. We've only got a few minutes for Q&A, so if you have a burning question, please do post it in the chat now. A couple came in. We've got Alex here to answer them, so welcome, Alex. One user asks, is it possible to modify the filters and create a dashboard to interact directly with the data?
Yes. So it's possible to create these interactive dashboards. So the tool allows us to define different filters connected to the queries, and then you can interact in real time with your data. So you can filter by time range, keyword, custom parameters. So depending on the needs of your analysis, you can customize the way you can interact in the dashboard. Yeah.
Great, thanks for that. Okay, maybe we'll just touch on one more. What is the accuracy of the family of translation models used in the use case? Yeah.
Well, so it depends on the model. Okay, so we haven't tested them all, but the ones that we've tested, they're quite reliable, but they are just small models for translation. So they're a bit biased based on the context in which certain words or terms were used or are used, because they do not work as dictionaries. So they do not translate word by word. They take into account the context of the sentence or the conversation. So, for example, this happened when we were developing the use case. When there was a sentence discussing about the city Barcelona, the model translated it as the Football Club Barcelona, the soccer team, because in the training context, it mostly encountered Barcelona in football-related context. But other than these small things, I would say it's quite reliable. It has high accuracy. They were really well for just translation.
The onus is sort of on the user to make sure that the response is correct. Yeah.
Yeah.
Okay, I think we've got time for one more. How complex was the process of achieving consistent and coherent sentiment analysis using an LLM?
It was an iterative process, so it was not in just one prompt, because as you've seen, we use LLM quite small. This LLM Llama, it's 3.2. It has 1 billion parameters. So being a small model implies that the reasoning capabilities that it has are limited compared to these large LLMs from commercial or big models. So it required a bit of several iterations to find the right prompt to get like the good sentiment analysis. But you have some techniques like the few shot prompting and so on that can help the model to know or to learn the way that they should work and they should perform this sentiment analysis. Giving some examples about this is negative and this is positive, so they can if you guide them a little bit, they work really well. But it requires some iterations and some.
Yeah. Nice. Okay, thanks, Alex. I think those are all the questions that came in during the session.
Okay. Thank you.
So we might just go on to the wrap-up slides. Yes, thank you. So, as mentioned earlier on in the session, this was the last workshop, but we do have some really interesting panel discussions and showcases coming up. Tomorrow, actually, we have a really interesting panel discussion with some project owners, and they will be presenting their use cases from various cities. I think we've got three projects to present, so you can sign up for that with the QR code here. That will be a really interesting one. That's tomorrow morning. And then to kick us off in the new year, we have a BDTI pilot showcase. So 2 or 3 pilot owners will be presenting what they've been able to achieve with the BDTI infrastructure. Some really interesting stuff going to be shown during that session. So do make sure you register for those. If we can go to the next slide, please. Yes, that's it then. You can learn more about BDTI by going to our website, and you can stay up to date. We send a newsletter once a month with all of the updates and news and activities from the team. So do make sure you sign up for that as well. I believe that is the end of our workshop today. So thank you very much again for joining us. That's it for the year. I wish you, we the whole team wish you a wonderful holiday period and a very productive new year. We will see you tomorrow, hopefully, for the panel discussion. And if you don't make that one, please do try to make the one in January. So we'll see you then, and have a lovely evening. Thank you again.